Large language models are powerful, but they often lack specific or up-to-date knowledge. That's where RAG, or Retrieval Augmented Generation, comes in. It's a key architecture for grounding LLMs with relevant, factual information. Standard LLMs, while impressive, suffer from key limitations. They can hallucinate facts, invent data, or simply be unaware of proprietary or recent information not included in their training data. RAG directly addresses these challenges by giving the LLM an external memory. At its core, RAG relies on a few critical components working in tandem. These include an embedding model to convert text into numerical vectors, a vector database to store these embeddings, a retriever to find relevant information, and the generator, which is the LLM itself. Before an LLM can answer questions using RAG, the external knowledge must first be ingested. This process starts with raw documents, which are broken into smaller, manageable chunks. Each chunk is then converted into a numerical vector embedding, capturing its semantic meaning. These embeddings, along with their original text, are stored in a specialized vector database, ready for fast retrieval. When a user asks a question, the RAG process kicks into action. The user's query is first transformed into an embedding, allowing for a semantic search. This query embedding is then used to find the most relevant document chunks in the vector database. These retrieved chunks act as context, augmenting the original user query. Finally, the LLM receives this enriched prompt and generates a grounded response based on the provided context. RAG and fine-tuning are often seen as alternatives, but they serve different purposes. Fine-tuning changes the model's weights, making it adopt a new style or knowledge implicitly. RAG, however, leaves the base model untouched, providing explicit, dynamic context without expensive retraining. RAG is generally more agile and cost-effective for rapidly changing knowledge bases. Modern RAG systems go beyond basic retrieval. Techniques like query transformation rephrase user inputs for better search. Re-ranking mechanisms then re-evaluate retrieved documents for optimal relevance before sending them to the LLM. These advancements significantly improve answer quality and reduce hallucinations. RAG has dramatically improved the reliability of LLM applications. For instance, Meta's original RAG model achieved a 40% improvement in factual accuracy on open-domain QA tasks compared to non-RAG baselines, demonstrating its powerful impact. RAG is essential for building trustworthy and domain-specific LLM applications. If you found this explanation useful, give us a like and subscribe for more deep dives into cutting-edge tech. Thanks for watching.